It's great that we have a running application, but we know that any application needs good tests to ensure it won't break with new development. In our synchronous applications, we had used unit test, but for asynchronous applications, I found that Pytest is a better fit. Pytest also has an Asyncio library that will allow us to test our code better. Let's update our PyProject TOML file to include all the testing dependencies and configuration we'll need. First, let's add our testing libraries to the dependencies section. We're adding several new packages here. First, we have Pytest, which is our main testing framework. It provides a more modern and flexible approach to testing than unit test, with features like fixtures and better async support. The Pytest Asyncio package is crucial for our asynchronous tests. It provides the tools we need to properly test coroutines and async functions in our Quart application. We're also adding SQL Alchemy utils, which provides additional utilities for SQL Alchemy that we'll use in our testing setup, particularly for database management during tests. Next, we'll add a new section specifically for Pytest configuration. The Pytest configuration section contains several important settings. The Asyncio mode setting tells Pytest Asyncio to automatically handle async tests. We set Asyncio default fixture scope to function, which ensures our fixtures are created and destroyed for each test function, giving us clean test isolation. We specify the test paths setting to tell Pytest where to look for our test files, in this case the tests directory. The Python files and Python function settings define the naming pattern Pytest will use to identify our test files and functions. They should start with test underscore. Finally, we set some default command line options with addops. The -v flag gives us verbose output so we can see exactly what tests are running, while -s allows print statements to show up in the output, which will be helpful for debugging. Save the file. Now let's configure our test settings in Settings TOML. We'll need two different test environments, one for running tests on our local machine and another for running them in our Docker container. In this configuration, we've set up two different testing environments. The testing section is used when we want to run our tests directly on our host machine. In this case, we set dbhost to localhost since we'll be connecting to a database running locally. We've also added a new Docker testing section, which will be used when running tests inside our Docker container. Here we set dbhost to db, which matches the service name of our database container in our Docker Compose configuration. Both environments set testing to true and use a separate database named apptest. Using a different database for testing is a best practice, as it keeps our test data completely isolated from our development or production data. Save the file. Next, let's update our Docker Compose YAML to add a test service. First, we'll update some paths in our existing configuration, then add our test service. We're creating a new service called test that extends our web service, which means it inherits all the configuration from our web service. This is a great feature of Docker Compose that helps us avoid duplicating configuration. The key difference in the test service is that we set env for dynaconf to Docker testing, which tells our application to use the Docker testing configuration we just created in Settings TOML. This ensures our tests run in an isolated environment with its own database. We also give it a unique container name, apptest1, to avoid any conflicts with our development containers. Save the file. Now let's set up our test fixtures using Pytest conftest.py mechanism. In the Pytest world, fixtures are powerful tools that help us set up the state our tests need. Think of fixtures as building blocks that prepare everything your tests require, like database connections, test data, or application configuration. The great thing about fixtures is that they're reusable across multiple tests and can even build on top of each other. Unlike our previous approach of having tests inside each blueprint, we're going to create a dedicated tests folder in the root of our backend service folder. This is a deliberate choice that brings several benefits. First, it gives us a clear separation between application code and test code. Second, it makes it easier to run all our tests with a single command. And third, it allows us to share fixtures and testing utilities across all our tests without duplicating code. Let's create our conftest.py file in the tests directory and walk through its implementation piece by piece. First, let's add our imports. We're importing everything we need to create our test environment, including SQL Alchemy utilities for database management, Quart's test client, and our application's components. Now let's create our first fixture that will handle the database setup for tests. This section handles the database lifecycle for both local and Docker testing environments. When running tests locally with Poetry run Pytest, the environment starts in development mode and needs to be switched to testing. However, when running tests on Docker, the environment is already set to Docker testing by our Docker Compose YAML configuration. After setting up the environment, it creates a fresh test database for each test and cleans up afterward. Next, we'll create our test application fixture. This fixture builds on top of the createDB fixture to set up our test application. It creates the application instance, sets up the database schema, and establishes connections. After the test runs, it properly shuts everything down and cleans up the database. Finally, let's create our test client fixture. This fixture creates a test client that we'll use to make requests to our application during tests. It depends on the Create Test App fixture, showing how Pytest fixtures can build on each other to create complex test environments. Save the file. Now let's create our first test file. Create a directory called counter app inside the tests directory and add a new file called testcounter.py. Let's write our first test. First, we import Pytest and Quart's testing utilities. The Quart client type hint helps our IDE understand the test client's capabilities. The Pytest mark Asyncio decorator tells Pytest this is an async test, which means we can use a wait inside it. Our test function injects the create test client fixture we created earlier. This fixture provides a test client that can make HTTP requests to our application. Notice that the fixture is typed as Quart client. This helps with code completion and type checking. We then make a GET request to the root path using the test client. Since this is an async operation, we use await. Similarly, getting the response data is also async, so we await that too. Finally, we verify that the string counter1 appears in the response body. This checks that when we first hit our counter endpoint, it properly initializes with a value of 1. Save the file. Let's run just this test to make sure it works. Since this is the first time running this container, it will take a little more time as it installs the new dependencies. But as you can see here at the end, it says that our test passed, although there's some warnings which are not related to our tests, but things that some libraries need to update. Now let's add our second test that checks the counter increment and database state. Here we test the counter increment. We make two requests. The first sets up our initial state, and the second verifies that the counter increments. The first hit returns the number 1 because each new test starts with a new database, as we have specified that fixtures are function scoped. We need both the test client for making requests and the test app for database access, so we inject both fixtures. Finally, we verify the database state. This is where we ensure the data was properly saved. We need an application context to access the database connection, which is why we use the async with statement. We create a simple select query, fetch all records, though we know there's only one, and verify the count is 2. The type, ignore comment, tells MyPy to skip type checking for that line since we know the DBC attribute exists, but MyPy can't verify it. Let's run the tests again. The tests pass, confirming that our counter application is working as expected. As you can see, this time the test Docker instance started much faster. We're now confident that our application is running correctly with the support of these tests.